Right, we are headed into section 2.4, where we're talking about the number of elements in various different sets. Now, you already took an opportunity to work on that first question on your worksheet. That was kind of a warm-up question, just to get your brain being creative and thinking about how to create different sets that contain different numbers of elements. I want to use another example to help us continue to get some intuition about this idea. So when we are working through this section, I want you to keep in mind that our big questions are things that we're focusing on is how many elements are in various sets. So if we do draw Venn diagrams and write numbers in them, then numbers represent a quantity of elements, not particular elements. So let's pretend that I have a class of students and I ask them a poll. So they're literally sitting in front of me in their chairs, and I ask them various questions. So first I say, all right, anyone from Kansas, raise your hand. So all the students who live in Kansas when they're not at school all raise their hands, and we sit and we count them. We count 1, 2, 3. We count 10 students. So there's 10 students who are from Kansas. Now, I ask another question. I say, all right, any student who plays football, raise your hand. They raise their hands. Some of them are reluctant. There's the student who has to punch his friend who's asleep to wake him up because he knows he plays football. And then again, we count their hands, right? So this time, 12 hands go up. So we've got 12 people who play football. Then I ask a third question. I say, well, how many of you are both? How many of you are from Kansas and you play football? So both, you live in Kansas and now at Sterling, you play football. So a fewer number raise their hands, but 4 people do. 4 people raise their hands and get counted. So now, this is all the information that we're going to have, and I want to ask a different question. I want to ask us how many students either are from Kansas or play football. So if I take all the Kansas kids and lump them with all the football kids, how many students are going to be in that group of people? So here's a first question for you. Is it, well, there was 10 kids from Kansas and 12 people who played football, so 10 and 12 is 22. Think about it for a minute, and I really, really want you to visualize this scenario in your head of what we're saying that this would mean. So is it 22 students? Picture the people raising their hands and picture counting them. Hopefully you've realized that this isn't going to be an accurate number. Because literally what's going to happen at this point, if I ask this question and people raise their hands, there are some people who were fitting in both categories, right? So what's happened is if I count the 10 people who raised their hands for being from Kansas, and then separately count the 12 people who raised their hands for playing football, there are certain people who I've counted 2 times, right? Say Billy is both. He plays football and he's from Kansas. I counted him once for being from Kansas, and then I counted him again for being a football player, but really he's one unique student. So the answer here with this would be no, because we counted people who played both, or who are both, twice. They're a part of the 10 and they're a part of the 12, right? We've got them counted extra times. There are not 22 individuals. There are only a less number than that. So let's try and think about what this would look like. So literally here what I've got, right, is I've got someone who's a Kansas person, Kansas, 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 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. But then what I have is some of those fit in both categories. There were 4 people who were from Kansas and play football. So this is going to be a Kansas football person, a Kansas football, Kansas football, Kansas football. Right? They're lumped. That's a single person. Now, in total, I had 12 people who did football. I already have 4 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If I count individuals now, if you picture these as being the hands raised, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Only 18 total. Now, a question that I have is how could we find that number with the given information that we have? Well, we could do it in 2 different ways. One way to do it is to think about starting off with our original idea, right? Our original idea was add the 2 groups together, but we noticed we overcounted, right? Certain people were counted twice. This person was, this person was, this person was, and this person was. How many people were counted twice? Well, everyone who was in both categories. So really what we could do is we could do the 10, which was the Kansas people. We could add it to the 12, which were the football people. And then I could subtract off the people who were counted twice, which then means, well, if I counted them twice and I get rid of one of those, then I only counted them once. So I could do the Kansas people plus the football people minus the people who do both, which was 4. So this is both Kansas and football. And if you do that, you get 18, which is the number that we wanted. This is one concept that we're going to use for this idea. Now, another way that we could do this problem is by using a Venn diagram to help us picture this scenario. So if we think about doing it with a Venn diagram, let's draw a Venn diagram for our scenario. We've got 2 different groups of people. There's the Kansas people and there's the football players. And what we want is to take advantage of that in this diagram, every region represents a unique set of people. So, for instance, this overlap region represents the 4 people who do both. You can almost picture it with how I drew these individual letters over here, right? We've got the Kansas people grouped in one group, and then we've got the football people in another group. And then we can look at the totals of how many are in those. Now, in the overlap, there's 4 people. Now, if we look at, say, the Kansas group as a whole, the total of them should be 10, which it is. But notice that includes these people who were only from Kansas and are not football players, and the people who were Kansas football players. The total of the whole circle is 10. So what that means is when I come over here to my Venn diagram, in this region, I don't want a 10 here because really 10 should be the total of the full circle, and that's only one portion of the circle. So what actually happens is I've already counted a portion of the people in the circle. From the total of 10, I've already counted 4 of them. So how many are left? Well, there's 6 left, which is exactly what we see here, right? We've got 1, 2, 3, 4, 5, 6 of them that are Kansas only, not football. So when we're putting in our quantities, we have to take into account what's already been counted because that overlap was already counted. So we've got the 6 and the 4. And then similarly in the football, the total is 12, but I've already counted, look, this portion of the circle has already been counted, which was 4 of them. So I'm left with only 8 of them. So if I ask a question of something like Kansas only, well, for Kansas only people in Kansas, not in football, there's 6. Football only, there are 8. And then in both, there are 4. And you'll notice with those, there's no one being counted extra times. Everyone is unique in that question. So if I add up all of those, 6 and 8 and 4 makes 18. Again, we find that correct total that we were looking for. So what we've actually done here is we've done the subtraction of the overlap just in a slightly different way. We did it in the process of creating our Venn diagram. So I've got 2 different takeaways that I want from this example. The first one is this: when writing quantities in a Venn diagram, notice the thing that we started with was what was common to all of the sets. So we started in the middle, start with the intersections. So start in the middle, and then work your way out, subtracting as you go. Right, we had to take into account what was already counted. Some of the parts of the circle were already counted, they were already written down, so we needed to take that into account in the total. The total of the circle should add up to the total number of people or objects. Second takeaway I have is we're going to have a formula for numbers of elements. And that's going to be relating back to this idea that we saw over here. So there was a way that we could take those totals and then we could combine them using additions and subtractions in order to get a total for this combination, for the either group. So what we saw over there is that, remember, notice, we were looking for the number in either A or B. The number in either A or B. That's like the number in Kansas or football. The way we found it was we took the number in A, right? The number of people over there was like the number in Kansas. We did plus the number in B. But then we said that counted too many, so we subtracted the ones that were counted twice, which was the number in both A and B. So the number in either A or B, so the or is the number in each added together, but minus the number in both. Now, this is kind of wordy in how it's written out. What we want to do is we want to condense that using our operations that we've learned. So first off, if we think about what it means to be either A or B, well, that was the union. Now, to represent the number of elements in a set, we're going to do a little n and then put it in parentheses. So this notation, n in front of a set, means the number of elements in that set. So the number of elements in A or B is the number in A plus the number in B minus the number. Well, we have to think about what was represented by both in A and in B. Notice that was that overlap, which is the intersection. So A and B. So we've got the number in the union equals the number in A plus the number of elements in B. Make that an obvious plus. Minus the number in the intersection. And the reason we're subtracting them is because they were counted, those people were counted 2 times. So by doing a subtraction, they're only counted once. We do want those people, they are important, but we only want to count them 1 time. So this is a formula that we're going to use in this class. So you can know that formula, but also this concept of how to put it in a Venn diagram is a different way to answer the same type of question. There are times where it's just easier to think about it one way or another way, so knowing both is important. What you're going to do at this point is you're going to hop on to your worksheet and you're going to work on the next couple problems there. And I think there's 2 of them next that you're going to work on, and you'll have video solutions for both of those. So again, if you need a push in the right direction, start part of the video and then just pause it and keep trying on your own. And once you're ready, once you're finished, watch the full solution. And then we'll hop on back here for one more at the board video.